Good morning, students. Today our topic is methods of expressing concentrations. For example, if I take one beaker, in that beaker I'm taking the water and I add salt in that water. So we have to express the concentration of that solution. Expressing concentrations are so many types. So number one, mass percent or weight percentage. Mass percentage or weight percentage. It is represented by W by W percentage. And the second one, mole fraction. It is represented by X. And third one, molarity. It is represented by capital M. And fourth one, molality. It is represented by small m. And normality. It is represented by capital N. And volume percentage, it is represented by V by V percentage. Mass percentage or weight percentage represented by W by W percentage. And volume percentage represented by V by V percentage. And the seventh one, mass by volume percentage. Mass by volume percentage. So mass W, volume V. So means W by V percentage. And last eighth one is parts per million. It is represented by ppm, parts per million. Okay, so there are eight expressing concentrations. So let us discuss about the first one, mass percentage or weight percentage, W by W percentage. So the first one is mass percentage, W by W percentage. So the formula is mass percentage. Mass percentage is equal to mass of solute, mass of solute divided by mass of solution. Mass of solute by mass of solution into 100. So here solution means solute plus solvent. Solute plus solvent. For example, if I take a beaker, in that beaker I am taking a water, and in that water I add salt. So in that the salt is a solute. The salt is a solute and water is a solvent. Water is the solvent. And combining of that solute to solvent is called solution. Okay. Let us solve one problem. A solution is prepared by adding 2 grams of a substance A to 18 grams of water and calculate the mass percentage of solute. So I'm taking one beaker. So in that beaker I have solvent. So to that solvent I'm going to add a substance A, is the solute, and this is the solvent, A is the solute, and calculate the mass of solute. So we have to calculate the mass of solute, that solute mass. So here we have that formula. What is that? Mass percent. So mass percent is equal to mass percent of A. Mass percent of A is equal to mass of A, mass of A means mass of solute. So A is the solute. Mass of A divided by mass of solution into 100 is equal to mass of A. Mass of A means mass of solute 2 grams. So 2 divided by, and mass of solution. Solution means solute plus solvent. So solute mass is 2. Solute mass is 2 plus solvent. Solution means solute plus solvent. Solute plus solvent. So solute mass is 2 plus solvent mass. So solvent mass, what is that solvent? Water. So here I am taking the water solvent. What is the solvent mass? 18 grams. So 18 into 100 and is equal to 2 by 20 into 100 is equal to 2 ones are 2 ones are. So 10%. So mass percent of A, mass percent of A is a solute. So mass percent of solute A is 10%. Next, second one, mole fraction. It is represented by X. The ratio between the number of moles of particular component and number of moles of all the component in the solution, called mole fraction. Sum of mole fractions is unity. For example, if I take one beaker here, so in that beaker I have two components, A component and B component. So solute A and solute B. So the ratio between the number of moles of particular component. For example, if I want A component mole fraction, so mole fraction of A is equal to number of moles of A divided by total number of moles of solution. Means A solute number of moles plus B solute number of moles. So here number of moles of A component, number of moles of A component is equal to Na. A component number of moles Na, and number of moles of B component is equal to Nb. There are two components in the solution. So mole fraction of A is equal to mole fraction of A means Xa is equal to number of moles of A, number of moles of A divided by total number of solution, means A plus B. So means here we can write that Xa is equal to Na, number of moles of A, Na, divided by total number of solution. Means in that solution we have two component, A component and B component. So A component number of moles Na plus B component number of moles Nb. So Xa is equal to Na by Na plus Nb. And next, mole fraction of B, mole fraction of B component. So Xb is equal to number of moles of B component divided by total number of solution, total number of moles of solution. Okay, so here total number of moles of solution and total number of moles of solution. So here, so Xb is equal to total number of moles of B, Nb, divided by total number of moles of solution, A component number of moles Na plus B component number of moles Nb, means total number of moles of solution. So this is for A component mole fraction and this is for B component mole fraction. So here if solution contain I number of components, then we can write that xi is equal to ni divided by n1 plus n2 plus n3 plus and so on plus ni. So we can write that ni divided by sigma ni for I number of components. In a given solution, sum of all the mole fractions is unity. All the mole fractions is unity. Means x1 plus x2 plus and so on xi is equal to 1. Means for example, in that solution there are two components. The two components mole fractions. A component mole fraction xa plus B component mole fraction xb. So these two mole fractions, sum of two components mole fraction is equal to 1. For example, there are three components in solution. So A component, B component, C component. xa plus xb plus xc is equal to 1. Okay, so means in a given solution, sum of all the mole fractions is unity. So this is about mole fraction. So sum of all the mole fractions is unity. For example, there are three components. So A component mole fraction 0.5 and B component mole fraction 0.4 and C component mole fraction 0.1 is equal to 1. So 0.5, 0.4, 0.9, 0.1, 1. So we'll get 1 is equal to 1. So sum of all mole fractions should be 1. So which component having more mole fraction and which component having less mole fraction doesn't matter. But sum of all mole fractions is unity. Next, third one, molarity, capital M. It is represented by capital M. The number of moles of solute dissolved in 1 liter of solution called molarity. If I take a one beaker, in that beaker I am taking 1 liter solution. So in that solution, the number of moles of solute dissolved in 1 liter of solution is called molarity. So molarity, capital M, is equal to molarity is equal to number of moles of solute divided by volume of solution in liters. So this is the formula. So molarity is equal to number of moles of solute divided by volume of solution in 1 liter. And the units are moles per liter. So here moles and liter. So moles per liter units are, and the units capital M. Capital M means molar. Okay, so the units are moles per liter or capital M. For example, if I take 0.25 moles per liter or 0.25 m NaOH. NaOH means 0.25 moles of NaOH present in 1 liter solution. Okay, so 0.25 moles per liter or 0.25 capital M NaOH, nothing but 0.25 moles of NaOH present in 1 liter solution. So if a gram of solute dissolved in V cubic centimeter, V volume of cubic centimeter of solvent, then we can write the formula molarity of solution capital M is equal to A by X into 1000 by V. So molarity of solution capital M is equal to A by X into 1000 by V. Or we can write that weight by molecular weight into 1000 by V in ml. So here X is equal to molar mass of solute. Let us solve one problem. 4 grams of NaOH dissolved in 250 ml of solvent. Then molarity of NaOH is, so here molarity of NaOH molarity capital M is equal to weight by molecular weight into 1000 by V. So weight is 4 grams divided by molecular weight. So X is the molar mass of solute. So NaOH molar mass 40 grams per mole. Okay, so here grams per mole and here grams into 1000 by V in ml, 250 ml. So here 250 ml. So here 1000 is the, so here ml per liter. So ml cancel, gram cancel. So that then the mole comes up. So then if you do this calculation, we will get 0.4 mole. This mole comes up and liters comes down. So mole per liter. So 4 grams of NaOH dissolved in 250 ml of solvent. Then the NaOH molarity is equal to how much? 0.4 moles per liter. And for dilute concentration, the formula is M1 V1 is equal to M2 V2 for dilute concentration. So let us solve one problem. How much volume of 1 m NaOH required to prepare 1 liter or 1000 ml of 0.2 m NaOH? So we dilute that NaOH from 1 m to 0.2 m. So the formula is M1 V1 is equal to M2 V2. So here M1 given. How much the M1 is? 0.2 and V1 given. So what is that V1? 1 liter. 1 liter means 1000 ml. And M2 also given 1 m. And V2. So what is that? V2. So we have to find out that V2. So the formula is M1 V1 is equal to M2 V2. So we need V2. So V2 is equal to M1 V1 by M2 is equal to M1 is equal to 0.2 into V1 is equal to 1000 ml divided by M2 is equal to 1 is equal to, we will get, if you do this calculation, we will get 200 ml. 200 ml means here take 200 ml of NaOH. So take 200. So this is the 200 ml NaOH. The molarity is 1m. Take 200 ml 1m NaOH and make it 1000 ml with distilled water to get 0.2m NaOH. So take 200 ml of 1m NaOH and take one standard flask, 1000 ml standard flask. So this is the 1000 ml standard flask, and take that 200 ml of 1m NaOH, 200 ml, and dissolve that NaOH with distilled water. How much distilled water we have to add? So the total volume is 1000. How much of distilled water? 800 ml. If you add 800 ml of distilled water to that 200 ml of 1m NaOH, then we will get how much of concentration? 0.2m NaOH. Let us solve one problem. Calculate the mole fraction of ethylene glycol. Ethylene glycol formula C2H6O2 in a solution containing 20% of ethylene glycol by mass 20%. Okay, so the ethylene glycol given in percentage. So we have to convert into grams. So 20%, we know that 20% of C2H6O2 means 20 grams. 20% means 20 grams, and the remaining 80% water. Remaining 80% water. 80% means 80 grams. So total 100 grams. 100 grams solution. And molar mass of ethylene glycol is molar mass of ethylene glycol C2H6O2 is equal to molar mass carbon 12. Carbon 2, there are 2 atoms, 2 plus hydrogen 6 into 1 6 plus oxygen 16 into 2 is equal, total we will get 62 grams per mole. Molar mass of ethylene glycol. And molar mass of water. Molar mass of water. So that water molar mass. So hydrogens 2, 1 into 2, 2 plus and 1 into 16 is equal to 18 grams per mole. So this is the molar mass of water. Now, so here we have to find out the mole fraction. So before find out that mole fraction, we have to find out the moles, because mole fraction is equal to a particular component moles divided by total number of moles. So here we have to find out moles. So first one, ethylene glycol moles and water moles. So C2H6O2. C2H6O2, how many grams? 62 grams. Molar mass 62. So 62 grams equal to 1 mole. Then ethylene glycol, how many grams? Only 20 grams. They are taken 20%, means 20 grams. So ethylene glycol 20 grams equal to how many moles? So cross multiplication. So 20 into 1 divided by 62. 20 into 1 divided by 62 is equal to 0.322 moles. And the second one, water. So H2O. H2O molar mass 18 grams. 18 grams per mole. So H2O 18 grams. 18 grams equal to 1 mole. But water, how many grams? 80 grams. So 80 grams. H2O 80 grams equal to how many moles? Next, here also cross multiplication. So 80 into 1 divided by 18 is equal to 4 point. If you do this calculation, we'll get 4.44 moles. So ethylene glycol 0.322 moles and water 4.44 moles. Next, come to mole fraction. Mole fraction X. Mole fraction X. So ethylene glycol mole fraction C2H6O2. XC2H6O2. Mole fraction of ethylene glycol is equal to moles of ethylene glycol moles of C2H6O2 divided by total moles. Total means moles of C2H6O2 plus moles of water H2O. So is equal to moles of C2H6O2 is 0.322 divided by moles of ethylene glycol 0.322 plus moles of water 4.44. So if you do this calculation, we will get 0.932. So this is the mole fraction of ethylene glycol. Next, mole fraction of water. We can find out that here mole fraction of water is equal to moles of water divided by moles of water plus moles of ethylene glycol. Then we will get the mole fraction of water. In another way, so we can find out that, so there are two components. One is the ethylene glycol and another one is water. So if you know one component mole fraction, automatically we can find out that mole fraction of other component, because the sum of mole fractions is equal to unity. So here XC2H6O2 mole fraction of ethylene glycol plus mole fraction of water is equal to unity 1. So we know this value. What is that? 0.932. 0.932 plus mole fraction of H2O is equal to 1. So mole fraction of H2O is equal to 1 minus 0.932. So if you do this calculation, we will get 0.068. So mole fraction of ethylene glycol is equal to 0.932 and mole fraction of water is equal to 0.068. Okay. So sum of these two mole fractions is equal to unity.